Hello, everyone. Welcome to the Lunchtime Discovery Series. I'm Carrie Woke, filling in for Chris Smith. Today, we're bringing you today's edition from the North Carolina Museum of Natural Sciences. The Lunchtime Discovery Series is coordinated by the Office of Environmental Education within the Department of Environmental Quality and is broadcast by us here at the museum. We have a great show for you today, so let's get into it. Today's guest is Dr. Francine McCarthy, geology professor and chair of the Department of Earth Sciences at Brock University in Ontario, Canada. Hi, Francine. I'm super
Hello.
excited to learn about your work and the
Great.
implications. So I'm going to turn it over to you. For those watching, we you're welcome to put your questions into the chat in our YouTube channel, and we will be taking those questions and bringing them to Francine at the end of the presentation. All right, let's go. I'm excited to hear all about the Anthropocene.
Okay, great. So I'm assuming you can see my PowerPoint presentation. So the question that was on the front page of the Geological Society of America Today magazine in 2008 was, are we now living in the Anthropocene? And it had been since the year 2000 that the man on the left, who was an atmospheric chemist, Nobel laureate Paul Crutzen, who stood up at a meeting in Mexico and said, stop saying Holocene. The Earth is too different now. We've altered the planet so much. Humans have made such an impact on it. We should call it the Anthropocene. And so it took 8 years for the geologists to pay much attention to this, because just because he was a Nobel laureate, he was just a chemist, not a geologist, and they ignored him. But then several journals were established with the word Anthropocene in the titles. People started using the term, geographers, environmental scientists, anthropologists, social scientists of various kinds. So finally, the geologists started worrying about this because they're the ones who are in control of geologic time. And so if you say Anthropocene, it sounds like Pleistocene, Holocene. So etymologically, the way it sounds, it is literally an epoch of geologic time. And that's what Crutzen had said. We're no longer in the Holocene epoch. We are now in the Anthropocene epoch. So, but are we? And we literally are not until the geologists say so and put it on the time scale. And in order for something to be on the time scale, it has to mean the same thing for everyone. And in these days of Zoom calls around the world, we all know how important it is to get your time zones right. If you join an hour early or an hour late, it's not good enough. So it has, if it's going to be on the time scale, it has to mean the same thing to everyone around the world. And there has to be a way that you can set your clock, like at Greenwich Mean. There has to be some baseline against which you set that. So in this talk, I'm not going to be trying to teach you about geologic time or paleoenvironmental reconstruction. I will show you a lot of data, and I really want to stick to why it matters. So the punchline then is that in order to get onto this timescale and have a little golden screw, a little golden spike, there has to be a place on the planet that exemplifies, that captures what it means to be living in an Anthropocene world on a planet that behaves differently from the Holocene world. And so the search was on, once the Earth scientists decided to pay attention to this term, the search was on for a place that has a geologic record that characterizes what it means to have transferred from the Holocene to the Anthropocene. And it turned out that the place that the Anthropocene Working Group voted on was the lake that I had been studying for a long, long time. And that's Crawford Lake in Canada. So it was advertised in the media. There was a press release, tons of interest in the whole concept. And it caused quite the scientific kerfuffle, which is the way that The Guardian put it in First Dog on the Moon. And one of my nerd friends was very impressed when my work made First Dog on the Moon, because apparently that's when you know you've made it. So it's basically about this kerfuffle that I want to talk today, and how that concept of are we or are we not in the Anthropocene has basically gone well beyond geology and science nerds. It's entered the world of pop culture, of film and entertainment. And this is one of the illustrations from an editorial that came out in the Washington Post a year or so ago. So it was the summer of Barbie and Oppenheimer, and it was also the summer of Crawford Lake. And they referred to Crawford Lake in their article about Barbie and Oppenheimer telling the same terrifying story, which I'll come back to in a few seconds. So the Anthropocene Working Group had recognized that what makes the Earth of today different from the Earth that had existed from 11,700 years ago to now is this massive increase in energy consumption, primarily the combustion of fossil fuels to produce that energy, and all of the other things that are associated with the post-war boom in, around the world, but primarily in the developed world. And as time went on, from the mid-20th century on, more and more countries became industrialized, heavily industrialized, and the population of our planet, the human population of our planet, increased. And all those things had tremendous impacts, socioeconomic impacts, and Earth system impacts. So this concept of the Great Acceleration is a social concept. The people who wrote this book are historians, for instance, but it is also one that has an impact on our planet. So the thing about the Anthropocene that's different from all of those other, Pleistocene and Holocene and so on, is that it's when human history meets Earth history. And those two things should speak, the same language. And for me, they do. But there are people who disagree with that assertion. So that's partly what I'll talk about today. So on this slide, there are some diagrams. The one at the top shows you in the blue line the amount of phosphorus fertilizer that was applied around the world to grow those crops for all those people. The dashed red line is the fallout of cesium-137, radioactive fallout from the nuclear bombs. And the little black line underneath is the record that we measured in the cores from Crawford Lake. And you can see that the cores from Crawford Lake perfectly mimic the global fallout of nuclear bombs. So that is really the question comes to us quite often: why are you using nuclear bombs, H bombs, hydrogen bombs, as the marker of this Anthropocene if what you're talking about is the Great Acceleration? And the diagram at the top left says the same thing, less poetically, as the Washington Post editorial. They are basically capturing the same moment in time, because the Great Acceleration started after the Second World War, and the Cold War that produced the fallout of radioactive things like cesium and plutonium followed at the same time. And the thing about the fallout of plutonium and cesium from the bombs is that it happens around the world all at the same time. And plutonium is one of those anthropogenic elements. So it's an isotope that doesn't exist in any appreciable amount on planet Earth, except when it was created by, through the fusion process in these H bombs by human beings. So it is an anthropogenic product, and there it shows up around the same time as that Great Acceleration. So it's a good marker of the Great Acceleration because it is globally synchronous. And so because the fallout is something that we can measure everywhere, even in Crawford Lake, far away from any nuclear bombs ever being exploded, it is something that we can use. And this is the record at Crawford Lake. And it's zoomed in. I'll just make it happen again at the top of the right-hand side. This is a photo of our core with all those annual layers. And the diagram that zoomed in is the measurement of plutonium in those sediments. And you can see it a bit more clearly on the top left. So that is a record of that first H-bomb in the Marshall Islands. November 1st, 1952 is the moment that the amount of plutonium increased dramatically. So if you've seen Oppenheimer, the amount of energy released when you explode an H-bomb compared to the old atomic bombs is radically different. And that's what we did propose to be the marker of the beginning of the Anthropocene. So just a couple of nice pretty pictures of how we got all these sediments. So you see measurements on a graph, and most people have no idea how much work goes into getting those measurements. So here we were, that's an aerial photo of the raft in the middle of Crawford Lake, and when we were taking our last set of cores. That is the core being born, being birthed, brought up from the bottom through the center of the raft. Here we are removing the core face from that freeze core and meticulously subsampling each and every annual layer, what we call a varve, which is a record of that calendar year. And so each calendar year was measured separately, and that's why we have years and the amount of plutonium plotted against them. So once we had the samples each year in little vials, we sent them to Southampton, where they processed them, prepared them for plutonium analysis. They then were shipped to Vienna, where a big accelerator mass spectrometer was used to measure how much plutonium was in each and every year. And those are the data that I showed you a few minutes ago that are the basis for our proposal that 1952, literally 7:15 in the morning in the Marshall Islands on November 1st, is the moment that would define the Anthropocene compared to the Holocene. But that is just the marker for when. The why is that great acceleration. So a couple of slides now to explain why Crawford Lake was chosen amongst those other sites. And I should probably go back because I didn't mention that there were 12 sites that were studied by the Anthropocene Working Group. They're behind me there on the screen. They are also shown in the diagram on the left that zoomed in, and that green line shows 1952. And you can see that at all 12 sites, there are blotches that are different kinds of markers that suddenly kick in. And I don't have time to describe what those all are. One of them is plutonium, and that is the fundamental one that we're using. Okay, so back to why Crawford Lake was chosen amongst all of those others. And one of the reasons is it has a really interesting backstory. It was the site of indigenous farming community in the middle of the last millennium. So between the 13th and 15th centuries, there were hundreds of people farming using the Three Sisters technique of agriculture that, through the northeastern United States and southern Canada. And the, one more thing, the interior of one of the longhouses on the right, there's a work of art, which is beadwork, which is wampum, that was created by an artist colleague of ours, who is a Wendat elder. She is an indigenous elder, a descendant of the people who are thought to have lived here. And that beadwork is showing, it is portraying those annual layers or varves that are so important to getting each and every year of record from Crawford Lake. So why does Crawford Lake have these annual layers? And it's because it's a very, very, very deep, 23, 24 meters almost, and small. You can walk around it in 10 minutes, 10, 15 minutes. So it's very, very deep and relatively small so that it doesn't fully turn over. That's what we call a meromictic lake. So in this meromictic lake, the diagram that zooms in the varved or annually layered sediments, we find two intervals of human impact on the lake. One was back the 13th to 15th centuries by the indigenous people in their Three Sisters agriculture that you see illustrated there. And then much later, European colonists came in and started to disturb the land. So that had been known for many, many decades. My master's supervisor, various colleagues, many people had focused on that indigenous interval and the early colonial interval. But so that's why one of my colleagues who had been on the Anthropocene working group for some time suggested that maybe Crawford Lake might be worth studying in this search for the golden spike because of that annual resolution, that ability to select individual layers of sediment and measure physical, chemical, biological properties of those sediments and know what happened each and every year. So I took on the challenge, and there you go. So one of the important things about Crawford Lake then is that within like 1 meter, like less than a meter, there are several different phases of anthropogenic impact on the lake that we can measure. But the concept that Paul Crutzen had enunciated back in the year 2000 is that the planet had changed, the entire Earth system. So the Anthropocene is not the same thing as when we begin to see anthropogenic impact somewhere, because that is not synchronous. It's not the same time all around the world. Some places had much earlier human impact and some places still don't have any at all. So it's not the same thing. And unfortunately, a lot of people can't seem to get that concept, because the way that it was conceptualized by Paul Crutzen, it was an Earth system shift. And the work that the Anthropocene Working Group has been doing is to see, is that captured in the geology of the planet? And it was captured at all 12 of the sites that we studied, best captured at Crawford Lake. So this slide, which I'm not going to focus on any of the data, but a couple of my grad students focused on what are those special aspects of that lake that make those magical varves happen, those summer and winter layers, light and dark, summer calcite that crystallizes in the surface waters, falls to the bottom, and winter basically fall through winter, die off of plankton living in the surface waters and the dark layers accumulating. And they're not disturbed because there's nothing living churning up the bottom. Of course, there's no wind that's able to get down there. So each layer is seasonal, summer versus the rest of the year, undisturbed. Every year a new one gets capped. And the layers of the lake that's meromictic, that doesn't fully mix, the bottom layer that is completely isolated from the rest of the world is a very, very different water body from the water above it. And that's the magic that I don't have time in this talk to focus on, but it is much more saline, very different chemical properties. And therefore, it's one of the things that helps preserve that record. So it's a multi-layered lake in a sense, and it's that magical bottom layer that allows us to have this ideal record, this ideal annual preservation of everything that's gone on for the last millennium. And so we can give calendar years to the different layers, and it's like a barcode. Each layer is quite distinct from the other one. The pattern is different, so it's impossible for people to miscorrelate. So that you know, the correlation is quote unquote perfect, no matter who is doing the sampling, which isn't the same in most sediments. So, and some more pretty pictures of us taking various cores. The easiest way to take our sediment cores is from the ice. Ice usually forms at the surface of lakes in Canada. Unfortunately, not so often anymore. So of the 6 years that we were studying the lake for the Golden Spike, there were only 2 that the ice was safe. And so that's why that first set of slides that I showed you, we had to resort to a raft, which is technically much more difficult, much more tedious to set up, ferrying back and forth to, and so on. So anyway, so most of the analyses we actually did, fortunately, were taken from the ice surface, and we only went back to get that last set of cores to cement our understanding of certain things, to prove beyond the shadow of a doubt to the rest of the world that Crawford Lake had a repeatable record. So I mentioned that in sediments from Crawford Lake, we see all kinds of things. And so we see evidence in sediments that we analyzed as part of our study, the 2 intervals of human impact, the indigenous, and then what we call the Euro-Canadian impact. And there are different biological and chemical characteristics that record that indicate that. And then, so previous slide. So the previous slide shows you the last almost millennium, well, basically the last 1,000 years. Yeah. But for the work on the Anthropocene, where we're looking at basically since the mid 20th century, we focus just on the very, very top 20, 30 centimeters or so. And that's what you see here. And the most useful proxy is the amount of fly ash from things like the steel mills that you see here that fall from the atmosphere into any body of water. And all the 12 sites that the Anthropocene Working Group looked at has a record of these fly ash particles because they fall out of the atmosphere. And it turns out that Crawford Lake is downwind from our steel town. So it's sort of Pittsburgh of the North. It's called Hamilton. And it's quite far away, but it is, the prevailing winds do carry steel, little fly ash particles from the steel mills and accumulate. I'm not going to talk about all the rest of the data. Oh, and they look kind of like this under a scanning electron microscope, so a bit like a meteoroid. So there are all kinds of things that on a dime in the mid 20th century change, recording that flip to the Anthropocene mode, biological things, physical things, chemical things, all sorts of what we call proxies or indicators that tell us that we're no longer living in the Holocene. And so this is what fly ash particles look like. Crawford Lake on the bottom graph, you can see 6 of those 12 sites that the Anthropocene Working Group looked at, and the second one is Crawford Lake. But you can see how similar the records are from the different sites. And the diagram at the top shows you globally from other people's work, not just our own, not just the Anthropocene Working Group, the record of these fly ash particles that are called spheroidal carbonaceous particles in fancy speak. So it is a very useful indicator of that the very beginning of what we call the Anthropocene. So why then is it important that we recognize that we're no longer in the Holocene? The world, the planet, is demonstrably different than the planet of our grandparents. It is interacting, the different components of our planet are interacting differently than they used to. Crutzen and his colleague Will Steffen referred to it as a no analog state. So the way the world is working now, we cannot compare, we can't rely on what we understand about the Holocene, which is since almost 12,000 years ago till 1952. We can't use all of that wealth of information to really understand how the planet's working. So I sometimes give the analogy is like when you are raising a child and suddenly they hit puberty and they're not behaving the way they used to. They're just not reacting to the same things the same way. And you're like, is this the same human being? Well, the punchline is it's a different planet. It's a different planetary system. It's an Anthropocene system. And if you do not accept that we are no longer in the Holocene, the decisions that you're going to make about how to deal with the planet in the future are not going to be successful. It's if you keep treating your teenager like he or she is 6 years old, you will not have a good relationship with that being, like guaranteed. So that's really the punchline. So the issue then is that the increase in greenhouse gas concentration in the atmosphere, which is what atmospheric chemist Crutzen first noticed, has an impact on all of the other aspects of the Earth system. It affects the water, it affects the organisms, it affects the ice sheets, it affects everything. It affects all of our planetary system. And if we look at how quickly things have changed, and if we project into the near future, not the distant future, but say by 2050, by 25 years from now, what are things going to be like? And the issue is that even if we reach net zero and everybody stop doing anything, the residence time of greenhouse gases is long, especially CO2. So it's up there, it's not going anywhere. It'll take a long time to dissipate. And the climate will still continue to warm, and all of the other interactions between the atmosphere and the rest of the Earth system are going to continue to happen. That's even if we all stop doing anything else, which of course we're not going to, and other nations are certainly not going to. And so it becomes a very political decision and so on. But the point is, we cannot go back to the Holocene. It is a myth that we're still in the Holocene, and it is equally a myth that we can go back there. What we can do is try to slow down the rate at which we're going down this brave new world and adapt to it, because there are some major what we call tipping points. There are major points where if our planet reaches certain temperature, global average temperature, if we look at the recent geologic record, our record of the recent past, we know that 125,000 years ago, for instance, the last interglacial sea level, global sea level, like all around the world, was 6 to 8 meters higher. That's an awful lot of land area in North Carolina that would be underwater if that were to happen. And last year, 2023, was the warmest year on record, and 2024 will probably be warmer. We are almost there. We're almost at those temperatures that we've reconstructed for 125,000 years ago. So we can't be sure when the Antarctic ice cap is going to become unstable and, melt in, parts of it will melt in the ocean. We can't be sure when, but we can be sure that it's not forever from now. It is probably within this century. It is possibly sooner than, the end of this century. So human beings, so that's the 2050 kind of prediction. Human beings have been around for a long time. They're adaptable and so on. But according to most climate models, by 200 years from now, we will have far exceeded the temperatures, the mean temperatures of our planet that any hominid, any human ancestor has ever experienced. And we are potentially heading toward the warmest temperatures of planet Earth that have ever been experienced through the entire Cenozoic era. That's since the dinosaurs became extinct with the meteorite impact that struck. So this little visual that just zoomed in shows you the sea levels of the last interglacial, which in Europe is referred to as the Eemian. Here in North America, we usually call it the Sangamonian, doesn't matter. You can see that we are currently well above that Holocene sort of range and heading toward that Eemian. Okay, so why is this important and what are we doing about it? Well, we are getting the message out. So several museums here in Canada have exhibits on the Golden Spike and, you know, the proposed base of the Anthropocene at Crawford Lake and so on. And a lot of people from all walks of life have been coming to presentations like this one. But we're also talking about what it means to humanity. I'm going to be speaking at the Vatican in 3 days. So the people around the world are anxious to know more about this, understand more about it, and consider what humanity can do and how it can adapt. So this was at the museum in Berlin, the Haus der Kultur in der Welt, an event that they had a few years ago. Various of us were discussing from a number of perspectives what it will mean, including an artistic perspective. So the artists, the indigenous artists who created the beadwork, based on the scientific work that I've been doing, it's transcending just a geologic story, and it is one that we have to continue to talk about. So in the journal Science, after the decision was announced in the newspapers by the International Commission on Stratigraphy not to add a line to the timescale, this was the headline. So the Anthropocene is dead. Long live the Anthropocene. And so there's some more images from the museum in Berlin. So my mission, if you will, is to make sure that the conversation goes on. Just because a group of geologists has decided not to put a line on the timescale doesn't make it not an issue. It is as much an issue as it ever was. And trying to pretend that we're still living in the Holocene is not serving anyone doing anyone any favors. And so this is a podcast of a radio broadcast that was out last week by Hannah Fry. So she looks at data all the time. She's a mathematician, and if you listen to it, she can't understand why this group of people is arguing that we're not in the Anthropocene and that this great acceleration of mid-20th century did not create the conditions that are substantially different from those of the Holocene. So I just came back from South Korea at the end of August, and there was a meeting of the International Geological Congress. They're the people who are in charge of the timescale. And they actually canceled what had been a planned Anthropocene plenary session. So one of the big sort of public sessions. And so they canceled it after the no vote by a group of old white guys, mainly, decided not to put a line on the timescale. And the reason that they gave, the chair of the Anthropocene Working Group, was that there was too much controversy around the topic, and it was too indecisive. It's not yet decided what's going to happen. Well, so this quote is from one of your presidents, and in my opinion, if there is something that is controversial, not talking about it, preventing people from talking about it is not the way to go about it. It's possible that I'm wrong and they're right. And, I and my colleagues are wrong and that they're right. But that doesn't mean that we shouldn't talk about it. And so it warms my heart to see not only geoscientists talking about it, but artists. So this is an exhibit that was at one of the universities here in Ontario a year ago, and well, 6 months ago, and they're visual artists, and they were fascinated by the idea of Crawford Lake, the Anthropocene, and the Merrimictic Lake. And on one of their walls, they had this really interesting presentation in a visual arts format of Crawford Lake's data, and very different from how I usually think of my data. But it to me, it's symptomatic of how far-ranging interest in this topic is and how important it is for us to continue to talk about it. So obviously, I didn't do this work alone. Many people were involved in the Anthropocene Working Group, in the studies on Crawford Lake. And of course, we interacted with the Indigenous people who are part of the Indigenous Council at Crawford Lake, which is in a conservation area. So I am indebted to many people for the work that we were able to do and the light we were able to shed on the altered state of our planet. And the land acknowledgement is at the bottom because as all of North America, we are on land that was the home of Indigenous people long before European people from elsewhere came to the area. And so I'll end it there.
Thank you so much. That was truly an interesting and enlightening talk about the Anthropocene. And I know a lot of us talk about climate change and how our planet is being affected by humans. But to put it into that geological perspective, I think maybe just a different lens to look at this situation that we're facing, all of us are facing as humans. So I do have a question from the chat. So Jens is asking, or they want to hear your thoughts on how the different members of the Anthropocene Working Group are dealing with the situation of the formal Anthropocene epoch rejection.
Yeah.
And I'd like to add just my personal question, and what are the next steps?
Yeah. I will say that we're still waiting for a formal response from that group that decided no to our 161-page proposal. So obviously, hundreds of people worked for years and years and years. All this money was spent on looking for geologic evidence of this transition from the Holocene to the Anthropocene. We found it at all 12 sites. Best site was Crawford Lake. Wrote up a proposal. When you send in a 161-page proposal with all kinds of data, and you hear in the news that people said no, you don't get a response. Like when you send in a scientific paper and it's rejected by the journal, there has to be an explanation for why, but in our case, so the Anthropocene Working Group, to get back to the question, we're still actually waiting for a formal response. We've heard in the media that the answer is no. We've heard from the organizers of that Congress in South Korea that they didn't want it officially to be talked about, even though it was the subject of so much conversation. And the president, in his opening remarks, mentioned the Anthropocene twice in a positive light and didn't mention any other interval of geologic time except for the Jurassic. And that's just to say most humans don't know any intervals of geologic time except for the Jurassic, but everyone's talking about the Anthropocene. So there's the Anthropocene Working Group is in a weird space because our proposal apparently has been rejected, we'd like to see what was lacking in it. So is it worth tightening up? So next steps, is it worth rejigging? What was it? We think it was very strong, obviously, but tell us what was missing. Maybe we can resubmit. There are no rules about how long you have to wait to resubmit. Like, various media reports suggest that there's a moratorium, but there isn't actually such a thing. So that's what happens when everything is filtered through, third-party sources. Stuff gets out there and misinterpreted and mismatched. And so we are continuing to spread the message, and which is the important part, but also waiting for an opportunity to address our proposal and hopefully resubmit it.
All right. Okay, Stacy is asking, is there a similar rise in the last epoch of the Mesozoic era? Or is there any data from that time that shows a similar rise or slash change?
So what happened at the end of the Mesozoic era was, that there were no hominids, dinosaurs and ammonoids and all kinds of things that are now extinct, unaware that this asteroid was hurtling toward the Gulf of Mexico. And then all kinds of things happened as a result of that impact. So I think it's a useful comparator because the moment that the asteroid hit is the moment that we call the end of the Mesozoic era. It would have taken decades, centuries for the last dinosaur, for instance, become extinct, to die, for the last animal. Everything didn't die all at once. It wasn't like poof, they're all gone. It's the similar analogy to the plutonium, the sharp increase with the first H bomb being the marker, but the great acceleration is still playing itself out 70 something years later. So we have a similar kind of record, but for different reasons.
All right. And so Stacey followed up with, wouldn't the ice cores be considered geologic evidence?
Yeah, there are ice cores. And they show very similar things to our sediment cores. The Antarctic site is ice core data. The 12 sites that the Anthropocene working group looked at are geologic data. One was a stalactite, 3 were lake sediments, one was the ice cores, peat bog. I mean, they were all geologic entities. And so our mission was to explore the geology of the planet to see if there is in fact a geologic record of that change from the Holocene to the Anthropocene, and undeniably there is.
Right. So Jen has wanted to add a little context. The working group member, Reinhold Leinfelder, was one of their professors back in Germany.
Oh, yeah.
And they saw him starting to analyze how he thinks the reaction happened. So that was some context.
Yeah. And in fact, Reinhold has taken an interesting approach in that he's co-produced a graphic novel about the Anthropocene. So our working group is looking at alternative ways of reaching a broad spectrum of society, recognizing that most people aren't going to listen to a dry scientific talk, but that, yeah, so Reinhold has this really good graphic novel. You should look it up.
I love that because that kind of leads me into the next question I wanted to ask you. So, if you were a young person who is concerned with the future of humanity and our planet, what would you recommend if you love science, you want to go into the scientific field, geology perhaps, what would you recommend being the direction to go for them?
Yeah, I think it's a little bit like the Thomas Jefferson quote that I had. The important thing is to be informed and to talk things out. Not everyone is going to agree on everything all the time, but we need to understand facts from fiction. There are things that we can pin our plans on in the future. Those are the factual basis for making decisions. And then there is erroneous information, fear, irrational fear. Like you can look at the future with dread, or you can look with the Chinese curse, may you live in interesting times. These are the times we're living in. So we haven't got any choice about the matter. How do we deal with it best? And being informed is the best way. So studying any kind of science, or for that matter, social science, because in my opinion, the work of the scientists is pretty much done. We've shown virtually everything there is to show. We need buy-in from the population. That's a social science problem, and I'm glad I'm not in charge of that one, because that's a much more difficult nut to crack. But yeah, definitely anything that we can, that young people can study to confirm the observations that we've been making, that they're not just sort of people drinking Kool-Aid in some kind of isolation bubble, but that it's real, it's not going away. We can't go back to the Holocene. And what do we do about it moving forward? And accepting that we're dealing with a teenager and not a child is the way to do it. Not pretending, oh, let's just keep buying him stuffed animals and that'll be okay. No, it's a teenager.
Which is I love that because I have a 13-year-old and I literally bought her a stuffed animal yesterday.
No.
As I end the analogy is just perfect. Um, so, and to speak to that, thank you so much for coming and speaking to our museum audience, because
Very
we
welcome.
are I feel that conduit, right, between the
Right.
science and the public. And so the more that we can inform our visitors and the folks who look to us for guidance about the facts and about science and about being scientifically literate,
Yeah.
and able to understand fact from fiction, that is, I agree, the path forward. So Francine, thank you so much for spending this time with us,
Very
and
welcome.
we appreciate it. And I wish the working group and you the best of luck, and we are all rooting for you. So
Thank you.
so thank you.
Okay, bye.
Bye bye.